This is SpaceTime, Series 22, Episode 64. Coming up on SpaceTime, a new map of the Milky Way's place in the universe. NASA announces its new mission to Jupiter's ice moon Europa. And the highly secretive S22E64 space shuttle spotted still in orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new map of the local universe has confirmed that the large-scale structure of the cosmos appears to be a honeycomb-like pattern composed of interconnecting filaments and strands, full of galaxies, galaxy clusters and superclusters, all surrounding vast empty regions or voids. Previous studies have shown that our Milky Way galaxy appears to be near the edge of one of these gigantic voids, with some studies even suggesting that it's within the local void. Now, a new study reported in the Astrophysical Journal has helped provide more detail about the Milky Way's place in the universe. Brent Tully and colleagues from the University of Hawaii have used the motions of galaxies to infer the distribution of mass responsible for that motion, thereby allowing them to construct a three-dimensional map of the local universe. You see, galaxies don't only move with the overall expansion of the universe, they also respond to the gravitational tug of their neighbours in regions with lots of mass. As a consequence, they're moving towards the densest areas, that is, the strands, filaments and connecting nodes of the cosmic web, and away from regions with less mass, that is, the voids. It was back in 1987 that Tully first noted that the Milky Way appears to be at the edge of a vast empty region, which he dubbed the local void. While the existence of the local void's been widely accepted, it's remained poorly studied because it lies on the other side of the Milky Way from where we are, and is therefore heavily obscured from our view by the galaxy centre. Now, Tully and colleagues have measured the motions of some 18,000 galaxies in the Cosmic Flow's 3 compendium of galaxy distances, constructing a cosmographic map that highlights the boundary between the collection of matter and the absence of matter, the region which defines the edge of the local void. In fact, they used the same technique in 2014 to help identify the full extent of our home supercluster of more than 100,000 galaxies, giving it the name Laniakea, which means immense heaven in Hawaiian. For more than 30 years, astronomers have been trying to identify why the motions of the Milky Way, as well as our nearest large neighbouring galaxy Andromeda, and all the other small satellite galaxies around us, which collectively make up what we call our local galactic group, seem to deviate from the overall expansion of the universe by over 600 kilometres per second. The new study shows that roughly half of this motion is generated locally from the combination of a pull from the massive nearby Virgo cluster and the Milky Way's participation in the expansion of the local void as it becomes bigger and even emptier. You're listening to SpaceTime. I'm Stuart Gary. NASA's approved a new mission to study Jupiter's ice moon Europa. The Europa Clipper will launch sometime between 2023 and 2025, taking at least 5 years to fly to the Jovian system. Europa is a vast, frozen water world, containing more liquid water than all the oceans on Earth. There's a growing chorus of astrobiologists now believing that life on Earth may well have begun in the hot geothermal vents of the Earth's mid-ocean ridges, kilometres below the surface. Scientists believe similar environments probably exist under the surface of Europa's oceans, and so Europa Clipper will tell scientists more about the potential for life on this and other worlds. The go-ahead decision allows for the mission to progress along the next stage of its development, completion of the final design, followed by construction and then testing of the entire spacecraft and its science payload. The Europa Clipper mission will build on the insights obtained from NASA's Galileo spacecraft, which visited Jupiter in the 1990s, and its Cassini mission to the Saturnian system in the early 2000s. Europa is the smallest of the 4 Galilean moons orbiting Jupiter, and the 6th closest to the planet of the 79 known moons of Jupiter. It's also the 6th largest moon in the solar system. It's called one of the Galilean moons because it was discovered in 1610 by Galileo Galilei, who named it after the Phoenician mother of King Minos of Crete and the lover of Zeus, the Greek equivalent to the Roman god Jupiter. Only slightly smaller than the Earth's moon, Europa is primarily made out of silicate rock, with a thick water ice crust covering what's thought to be an iron-nickel core. It also has a very thin atmosphere composed primarily of oxygen. It's been estimated that Europa has an outer layer of water around 100 kilometres thick, partly frozen as a crust on the surface and partly liquid beneath. Magnetic field data from the Galileo orbiter showed that Europa has an induced magnetic field through its interaction with Jupiter's magnetic field. Now, all that suggests the presence of a subsurface conductive layer, and that layer is very well likely to be a salty liquid water ocean. It's also worth pointing out that portions of Europa's crust are estimated to have undergone a rotation of nearly 80 degrees, in fact nearly flipping over, and that's unlikely to have happened where the ice solidly attached to the mantle. Furthermore, Europa's surface is heavily striated with cracks and streaks, yet it has relatively few craters, suggesting a continuous process of resurfacing, probably from the Moon's subsurface global ocean, giving Europa the smoothest surface of any known solid object in the solar system. So, with evidence mounting that Europa probably does have a thick liquid water ocean underneath a frozen crust, that raises the question, how could a body so far from the sun and clearly on the wrong side of the snow line find enough heat to remain liquid rather than being frozen solid? The predominant model suggests that it's heat from tidal flexing as Europa orbits around Jupiter, which causes the oceans to remain liquid, while at the same time driving ice movements similar to plate tectonics on the surface, in the process absorbing chemicals from the surface down deep into the ocean below. Meanwhile, sea salt from this global subsurface ocean may be coating some of the geological features on Europa's surface. And that sea salt looks like it's full of minerals, which means the ocean is interacting with the seafloor. And this may be important in determining whether Europa could be habitable. Those minerals being dissolved at the seafloor could provide nutrients for any possible life, just like chemosynthesis does for much of the life at Earth's mid-ocean ridges. Scientists have also observed water vapour plumes erupting from the surface of Europa, and these are thought to be very similar to the cryogeysers observed spewing out of the South Pole tiger stripes on Saturn's ice moon Enceladus, which is also thought to harbour a deep subsurface global ocean. By fitting the right scientific instruments on the Europa Clipper, scientists could swoop through this plume activity in order to take a chemical analysis of what's in it, an easy way of searching for signs of life in Europa's subsurface oceans without having to actually land and drill through kilometres of ice. To find out more, Andrew Dunkley, better known as Dave, is speaking with astronomer Dr. Fred Watson.
One step closer to happening, a mission to Jupiter's ice moon Europa.
Very good news from NASA. That powers that be within NASA have given the go-ahead for a mission called Europa Clipper, which is one of the missions that's been postulated, or proposed is a better word, for exploring the moons of the outer planets. There are a number that are on the table at the moment, some further advanced than others. But Europa Clipper is pretty well advanced, and as you can tell, its main target is Jupiter's moon Europa, which is one of these ocean moons, ice ocean moons. We believe it has covering of ice, and we don't know whether it's thin ice or thick ice, so that will be one of the things that Europa Clipper would find out, and an ocean underneath it and a rocky core. So Europa Clipper, I think they are talking about having it ready for launch in 2023, which is fantastic if they can do that. That's right. But apparently that's the baseline commitment, as it's called, supports a launch readiness date by 2025. It's all being done at the Jet Propulsion Laboratory in Pasadena. That's where the spacecraft will be built. So they've got the go-ahead, the next step in approval from NASA, which I think is a pretty solid one. So
what will be the basis of the mission? Are they just going there to have a look? Because
it is a bit like that, but it's a very good look. So it's not going to land on Europa. Okay. It is a proposal to go into orbit around to go into orbit around Jupiter. And of course, orbiting Jupiter is always hazardous because of the intense radiation belts that Jupiter has. It's got a magnetic field thousands of times bigger than the Earth's and has these high energy radiation belts around it that threaten to melt the innards of spacecraft. So like the Juno mission, which is currently in orbit around Jupiter, Europa Clipper will go into a very elongated orbit, which will give it 45 flybys of Europa, and their altitudes will vary from 2,700 kilometres to 25 kilometres, so it will really be skimming over the surface.
Sure will.
And it's got this huge science package with all the kind of the gubbins that you would expect to find on board something like that, including a mass spectrometer, which basically measures the weights of atoms, as you might guess. That is interesting because Europa, like Saturn's moon Enceladus, is thought to have, although it hasn't really been properly confirmed, but thought to have ice fountains coming out of it, which are water that's squirting up through its icy shell and it instantly freezing. It's snap frozen. But if you fly through it, as Cassini did with Enceladus, then you can sample what the atomic makeup is. And so the mass spectrometer will help with that. And also, it's got this ground-penetrating radar, and that's going to be crucial in characterizing Europa's crust and revealing how much of, the potential water within is oceanic, as is expected, or whether it is just pockets of water as we find in Antarctica and indeed around the South Pole of Mars.
Will they be able to tell what kind of water it is?
To some extent, they will. It may require a bit of inference from other measurements, but if you've got samples of ice crystals, then you can do exactly that. You can basically tell whether it's saline water or fresh water because you can measure the salt content of it. So like Saturn's moon Enceladus, which is actually quite rich in minerals, and it's the silicates in that tells you that this water was once in contact with rock. I think the Europa Clipper will be able to sample exactly those things too, assuming these plumes are real, because they're not well observed. There is evidence, I've seen images that seem to show these plumes coming from Europa. Assuming they're real, when they fly through, hopefully we will be able to tell what kind of water it is exactly.
And will they be able to tell how much water there is underneath the surface?
Yes, they will, because that will very much be revealed by the ground-penetrating radar in exactly the way that one of the spacecraft in orbit around Mars, might even have been Mars Reconnaissance Orbiter, I'm not sure, detected this lake of liquid water underneath the ice cap of the southern ice cap of Mars about a year ago. And they can tell exactly how much there is there because with this sort of radar, you can see the boundary between an ice surface and a water surface. And that's crucial to doing this.
So this mission won't actually be looking for life, but it will be looking for the potential for life to perhaps exist on a moon like this.
Exactly. So as the blurb on the NASA website says, it will help scientists investigate the chemical makeup of Europa's potentially habitable environment while minimizing the need to drill through layers of ice. So that what they're going to try and do is as much as they can from orbit. And then, if they find lipids and amino acids and all this sort of thing in the plumes of ice coming from Europa, then clearly the next step will be a lander that starts digging holes in the ice.
Yes.
Before you do that, the first thing you need to know is how thick the ice is.
Yes. If it's a couple of miles thick, we've got problems.
Well, actually, a couple of miles is better than what they're expecting.
Oh, is that right?
Expecting more like 25 or 30 miles or kilometres. That's right. Choose your units. Yeah, so a thinnish layer of ice will be pretty good to cope with. You could probably do that. By thin, I mean less than a kilometre probably.
Yes, but the likelihood is it's probably more. But I guess we'll have to wait and see.
The thing is, and Europa's covered in all these cracks that are brownish in colour.
Yes.
That's thought to be the effect of sunlight on brine, basically on salt water. So you've already got a hint there that it's probably a salty ocean underneath the surface.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. An amateur Dutch astronomer has spotted the US Air Force's mysterious X-37B robotic space shuttle. The X-37B spaceplane is currently conducting its fifth mission in orbit. The Air Force won't say what it's doing up there or how long it will remain in orbit. Ralph Vanderberg, who regularly takes close-up images of spacecraft in Earth orbit, says he first saw the highly classified spaceplane back in May, and then tried to image it in mid-June, only to find that it had changed orbits. But thanks to the Amateur Satellite Observers Network, it was located again by the end of the month. The X-37B was originally designed as a NASA project. The robotic reusable wing spaceplane was to be launched into orbit inside the payload bays of NASA's Space Shuttle fleet, and then released to undertake their own missions, including the deployment of satellites from their own payload bays, rendezvousing to repair or modify other satellites in orbit, and capturing orbital satellites for return to Earth. However, following the 2003 Space Shuttle Columbia disaster, the X-37 was modified to launch from Delta II rockets instead. It was then transferred from NASA to the US Air Force the following year, and the project became classified. After that, things start to get a bit sketchy. We do know it carried out a series of glide tests using the Scaled Composites White Knight mothership. And in 2006, the US Air Force announced that it would proceed with a variant of the original NASA X-37 to be called the X-37B. Because of concerns over the unshrouded spacecraft's aerodynamic properties during launch, the new X-37B variant was designed to fit inside the payload fairing of an Atlas V rocket. Boeing built two of the spacecraft, designating them as X-37B orbital test vehicles 1 and 2. The first X-37B was launched on its maiden mission, OTV-1 USA 212, on an Atlas V rocket launched from Space Complex 41 at the Cape Canaveral Air Force Station in Florida on April 22, 2010, on what the Air Force described as a test flight. Amateur space watchers noted that the spacecraft's ground track was observed to repeat every 4 days, which was considered indicative of a possible imaging reconnaissance mission profile. Then for 2 weeks, amateur skywatchers were unable to find the spacecraft in the locations they had predicted, leading them to believe that it had suddenly changed its course. In fact, during the mission, the vehicle was observed to change its orbit multiple times, with a total delta V of 4 orbital changes, amounting to 102 meters per second. A common characteristic of all the orbits was that the ground track nearly repeated every few days. By November, the orbit had been lowered to 281 by 292 kilometers, with the ground track now repeating every 3 days or 47 orbits. It successfully landed autonomously at the Vandenberg Air Force Base in California on December 3, 2010, after 224 days and 9 hours in orbit, becoming the first spacecraft, other than the Russian Buran space shuttle, to carry out an autonomous landing from space. The second X-37B, launched on its inaugural mission, designated OTV-2 USA 226, also aboard an Atlas V rocket from Cape Canaveral on March 5, 2011. The mission was classified and described by the US military simply as an effort to test new space technologies, demonstrating various experiments, and allowing satellite sensors, subsystems, components, and associated technologies to be transported into space and back. In addition to its classified payload, OTV-2 also carried a folded solar sail panel in its cargo bay, needed to power the spacecraft during its long mission. It landed autonomously at the Vandenberg Air Force Base on the 16th of June 2012 after spending 468 days and 14 hours in orbit. The third X-37B mission and the second flight for the first of the X-37Bs was OTV-3 USA 240. It launched aboard an Atlas V rocket from Cape Canaveral on the 11th of December 2012. The Air Force gave no details of its payload, saying only that the flight would test modifications made to the spacecraft following its first mission. It finally landed back at Vandenberg almost 2 years later, on the 17th of October 2014, after a mission lasting some 674 days and 22 hours. The fourth X-37B mission was codenamed AF-SPC-5 and designated as OTV-4 USA 261. It flew into orbit on May 20th, 2015. It was the second flight for the second X-37B vehicle, and again it launched aboard an Atlas V rocket from Cape Canaveral. We know the flight tested Aerojet Rocketdyne's XR-5A Hall effect thruster in support of the Advanced Extremely High Frequency Communications Satellite Program, and it also carried a NASA investigation to test the performance of various materials in space for at least 200 days. The vehicle spent what was then a record-breaking 717 days and 20 hours in orbit, before landing at the Kennedy Space Center Space Shuttle Landing Facility on May 7, 2017. The fifth X-37B mission, which is currently in orbit, was designated USA 277 and launched on September 7, 2017 aboard a Falcon 9 rocket from Space Launch Complex 39A at Cape Canaveral's Kennedy Space Center. This was the third flight for the first X-37B vehicle. Interestingly, the spacecraft was inserted into a higher inclination orbit than previous missions, further expanding the X-37B's envelope. During the flight, the spacecraft modified its orbit using its onboard propulsion system. While the complete mission payload's unknown, the US Air Force did confirm that one of the experiments flying aboard was the Advanced Structurally Embedded Thermal Spreader 2, developed by the Air Force Research Laboratory to test experimental electronics and oscillating heat pipes. The spaceplane's been orbiting Earth in obscurity for over 20 months now, on what's likely to become its longest mission so far. As to when it returns to Earth, well, we'll let you know that when it happens. Right now, the 6X-37B mission OTV-6 is planned to fly on an Atlas V 501 rocket around December this year. Processing for the X-37Bs are done inside Bays 1 and 2 at the old Space Shuttle Orbiter Processing Facility at the Kennedy Space Center, where the vehicles are loaded with their top-secret payloads. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study by the Heart Foundation claims unflavoured full-fat milk, yogurt and cheese are now an acceptable option for a healthy diet. But the study also found that many Australians need to rethink how much red meat they're eating, as evidence indicates it increases the risk of heart disease and stroke and can lead to weight gain. The Heart Foundation's chief medical advisor, cardiologist Professor Gary Jennings, says its latest study recommends a limit of less than 350 grams per week of unprocessed beef, lamb, pork or veal. That equates to only around 1 to 3 lean red meat meals per week, like a traditional Sunday roast or a beef stir-fry. The Foundation says processed or deli meat should be limited, as they've been consistently linked to higher risk of heart disease and other chronic conditions. Instead, it says people should be getting most of their heart-healthy protein from plant sources, such as beans, legumes and tofu, as well as seafood, with a smaller amount coming from eggs and lean poultry. It points out that heart-healthy eating is more about the combination of foods eaten regularly over time. While the evidence remains mixed, it seems consuming full-fat milk, cheese and yogurt appears to have a neutral effect on the body, in that it neither increases nor decreases your risk of heart disease or stroke. However, people who suffer high cholesterol or heart disease should stick with unflavoured reduced-fat milk, yogurt and cheese, and consume less than 7 eggs per week. The bad news is that butter, cream, ice cream and dairy-based desserts are not recommended as heart-healthy, as they contain higher fat and sugar levels and less protein. The study found that the dairy fat in milk, cheese and yogurt does not raise bad LDL or low-density lipoprotein cholesterol levels as much as butter or other dairy products. A new study suggests that living in cities with high traffic pollution may increase the risk of developing age-related macular degeneration, an eye condition that affects the middle part of the retina and is the most common cause of poor vision in the elderly. A report in the Journal of Investigative Medicine found that in areas with the lowest traffic pollution, around 3 people in every 100 develop age-related macular degeneration. However, in areas with the highest pollution, between 5 and 6 people in every 100 develop it. Scientists investigating the effects of ocean acidification on diatoms, a key group of microscopic marine organisms and phytoplankton, have identified a new threat from global warming. Reporting in the journal Nature Climate Change, researchers found that ocean acidification is negatively impacting the extent to which diatoms in southern ocean waters are incorporating silica into their cell walls. The findings are important in the context of global climate change because of the implications for global carbon and silicon cycles and ultimately for ocean productivity. A new study warns that using antibiotics could increase your risk of bowel cancer but also lower your risk of rectal cancers. The findings, reported in the journal Gut, are based on more than 23 years' worth of data from 11 million UK residents. Scientists believe that differences in the gut microbiome along the bowel tract could potentially explain the differences. After taking into account other risk factors, the study's authors found that short doses of oral antibiotics were linked to higher rates of bowel cancer, yet antibiotics used longer than 60 days were associated with a 15% lower risk of rectal cancers. Alongside the global threat of antibiotic resistance, these findings strengthen the case for even greater care when using these drugs. Doctors may soon be able to predict when you're going to die of natural causes up to 10 years in advance by using a simple blood test. The findings, reported in the journal Nature Communications, are based on a 17-year study of the metabolisms of 44,168 people aged 18 to 109. Scientists found 14 biological markers that appear to be closely associated with death in patients. It's thought these biomarkers could be used to form the basis of long-term death predictions, giving patients 5 to 10-year risk scores. Well, in case you didn't know not to trust anything you read online, except SpaceTime, of course, a new study looking at 100 of the most popular health stories online in 2018 has found most of them are either fake or at best misleading. The study was put together by a bipartisan network of scientists who collectively assessed the credibility of media health coverage, specifically those stories with the highest number of social media engagements. And they weren't just looking at conspiracy website garbage. They studied stories from numerous well-known websites, such as Time, National Public Radio, The Huffington Post, The Daily Mail, New Scientist, and CNN. Of the top 10 shared articles, scientists found that 3/4 were either misleading or included some false information. In fact, only 3 were considered highly creditable. Some stories lacked context of the issue, exaggerated the harms of a potential threat, or overstated research findings. Tim Mendham from A Strange Skeptic says many writers either twisted the data or simply couldn't properly interpret it, while it would appear others had their own agenda.
This was a study done by a number of scientists and things and people who were an organisation largely called Health Feedback. They were the main people looking into it. They looked at the 100 most popular health articles as published in 2018, and they found that the vast majority of those, about 3/4 of them, were either misleading or false, or included some false information. Some stories and things are shared hundreds of thousands of times. Therefore, the impact they have is very great. There's a thing called rumour cascading, which is people who put out a conspiracy theory or something like that on Twitter, and it just builds up and up and up and up until, from one source it becomes hundreds of thousands of followers, etc. And this is the sort of thing that's happening here, that these initial stories, often done by journalists who don't have a health background or people who have an agenda in some cases.
Or they're selling some product. I would suggest I'm a bit more generous. I would tend to go for inept rather than evil. But it's hard sometimes if you're a journalist to cover a lot of different stories, so there might be errors.
It's the problem whenever you have general reporters dealing with specialist issues like science. I remember when I was working at the ABC and editing the news, I found as soon as the journalist was assigned to a story that required some sort of technical understanding, they almost always made assumptions that were simply wrong. They'd simply failed to check the scientific facts of their story, and then they would inevitably get offended when I corrected them, which was my job. I guess in that way, the Australian Broadcasting Corporation's newsroom was very much a sheltered workshop, at least the Sydney one was where I worked. And that was very different from ABC Science, where the journalists there all knew their stuff. In fact, there, the boot was on the other foot. They had to help me improve my journalism because I was trained as a broadcast journalist, specialising in radio and television, rather than the newspaper style of copy, which is used by Science Online. And so there, I was the one who needed the help.
But certainly there are others out there which are consciously misguided and scare tactics, basically, and that obviously, sort of clickbait for online stories is a pretty important issue for a lot of journalists trying to keep their jobs. The thing about this particular study was that so much of the stuff is faulty. It's not just like a little dribble here, the bad apple. This is a crate full of bad apples.
And these are major publications. We're talking about organisations like Time, National Public Radio across the United States, the Huff Post, New Scientist, CNN, and of course you can also include lots of Australian groups in that too. How many magical cures have we seen on a current affair?
Yes, exactly. And that's why I think that because of this range of publications, and because some of these are sort of journals of note, others are not. They also looked at the Daily Mail, which is notorious for having a lot of shall we say, unsubstantiated stories. But that, to me, indicates the variety of motivations between these. Some are just inept, some of them are accidents, some of them are actually just out there to actually gather attention and get some clicks online.
That's Tim Mendham from Australian Skeptics. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.